Hello, a very good morning to you. It's Friday, the 30th of September. I'm Anita McVeigh and welcome to BBC Newsroom Live. It's one of the most complicated and difficult missions ever undertaken by a spacecraft. But the 12-year journey by the Rosetta probe is about to come to an end. In the next hour or so, it will be deliberately crashed into the Comet 67P, which it has been orbiting, tracking and photographing for the past 2 years. Rosetta is so far out in space now that its solar-powered instruments are failing, but before impact, it's expected to send back some more stunning images of the comet. Well, joining us now from the European Space Agency in Darmstadt in Germany is our science correspondent, Rebecca Morell. Rebecca, hello to you. I think it's no exaggeration, is it, to say that this has been an epic undertaking and an epic journey?
Yeah, I mean, it really has, and scientists here at Mission HQ are really gearing up for what is going to be a dramatic finale to this mission. And I think it's fair to say it's probably been one of the most bold and possibly bonkers missions in the history of space exploration. This idea of chasing down a comet that's hurtling through the solar system. It took 10 years to get there, getting a spacecraft in orbit around it, then putting down a little robot onto its surface. But all good things have to come to an end, and rather than letting this mission kind of fade out into the oblivion of deep space, well, they're going to go out in style, and that's with a crash landing.
A final farewell to Comet 67P, and a trailblazing mission that's given us these stunning images. The Rosetta spacecraft's been orbiting this alien world for the last 2 years. Now, though, its power's fading, and a crash landing will bring the mission to a close.
It's mixed emotions. It's sad on the one hand that this is over, but we've achieved something fantastic. There's the excitement of what we've achieved already by doing this mission, and the huge amount of science we have that we've only just started to scrape the surface with. We will have decades of work still. So the operations end now, but the science continues.
Décollage.
The Rosetta mission blasted off in 2004. And after a 10-year journey, it made history when it dropped a small robot onto the comet's surface. After a bumpy touchdown, the robot stopped working after a few days. But the next landing of its mothership will be even tougher.
The Rosetta spacecraft was designed to fly to the comet, around the comet, but not to land on it. And there's no doubt that as soon as it touches down, it's going to be destroyed. But it gives scientists the chance to squeeze every last drop of science out of this mission. And all the way down, it's going to be taking close-up photos and collecting data.
Rosetta's transformed our understanding of comets, but it's also a mission that's captured the public's imagination.
Well, the instructions to stop the spacecraft from actually orbiting the comet and send it heading straight down for its surface were uploaded last night. And it's been in freefall going down. It's actually moving pretty slowly, and by the time it hits the surface, it will be at walking pace. So it's probably not so much as a crash as a kind of controlled collision with the surface. But it is going to be destroyed, I'm afraid to say, by this process. Now, I'm joined by Professor Mark McCaughrean, who's a senior science advisor at the European Space Agency. How are the team feeling here today? I've seen lots of people holding some tissues and hankies ready for the moment of landing.
Well, as I've been saying all morning, I wish people would stop asking me that question, because as soon as I start thinking about it, the emotions start coming. The team, I think, are on the edge. They're very proud of what they've done. I mean, today, of course, is the final act in their operations. The science continues afterwards. We've got all these data, but there's going to be lots of people, mixed emotions coming up. And I'm almost there now, but in an hour and 20 minutes or so, we'll have confirmation, and I think you'll see the floodgates open.
I mean, the landing itself is a chance to just squeeze a bit more science out of this mission. It's heading for the head of the comet. What are you hoping to learn as it's making its way down?
Well, up on the head of the comet, there are some open pits, holes in the ground, effectively, which are about 100 metres across, 50 metres deep. And these are not made by impact, stuff hitting from the outside, but it's actually materials flown away from the inside, been heated up and just gone out as a gas and left a big hole underground, and the roof has collapsed, and we can look down in the pits and see on the walls it's the real interior of the comet. It's what it's like on the inside. We've only ever seen the surface really before in detail. So now today we're going to investigate that with pictures, but we'll be taking all sorts of other data, measuring the gas and the dust all the way down to the surface. So it's one last chance to do some amazingly unique science, then it's all over.
This mission wasn't cheap. It was 1.4 billion euros. Has it been worth it? What have we found out?
Well, I think, when it comes to basic research like this, of course, if you want to understand a comet, you've got to go and catch one. You've got to go and chase one. You can look at them from Earth, but this was the game, was to actually go and catch one. Of course, that money's all spent on Earth. It's in engineers, it's in technicians, it's in scientists. But, one of the other things which we feel very proud of is just the level of public engagement, the amount that people have become attached to the mission, not just because it's kind of cute, Rosetta and Philae talking to each other out in space, and the journey, the story, and today the sad part, but because people have actually got the fact that we're doing something which is about them. It's about the birth of the solar system and potentially the origin of life on the planet Earth. And what could be more personal?
And what have we actually learnt? We've been up close to this comet for 2 years. We've set down on the surface of it a couple of years ago with Philae. What have we found out?
Well, we've got an inventory of all sorts of organic molecules, complex molecules, and another thing, oxygen, for example, which was never expected to be detected in a comet. You might think, well, there's plenty of oxygen on the Earth. Why wouldn't there be in a comet? Well, normally it would react. And for it to be still locked in the comet today, 4.6 billion years later, it must have been locked into the ice at a very cold time, a very distant place in the solar system. So we're learning about how the solar system was put together. All these organic molecules are also the building blocks of life. And if you chuck a bucket full of organics at a planet like the Earth 4.5 billion years ago, it could have been part of the kickstart process for where we are today.
Well, Professor McCaughrean, thank you very much for that. And we're going to be tracking the final moments of the Rosetta mission as it descends its way down. Some of the images that it's been sending back already as it's been kind of heading in freefall gently down to the surface have been absolutely spectacular. And we're hoping that some of the last ones are very up close. The trick is going to be to take the photo and send it back to Earth. We're a long way away, 700 million kilometres. It takes 40 minutes to send that information back. It's working at kind of something akin to dial-up internet speed. So the challenge is going to be to take the snap, get it back here. But it has been a remarkable mission for the team here. And there is a real mix of emotions here today, both pride at what's been achieved and sadness that this part of the mission, at least the operational part, is coming to an end.
OK, well, Rebecca, we'll be back with you soon. Thank you very much, Rebecca Morel in Germany for us at the European Space Agency. And with me now in the studio is Libby Jackson from the UK Space Agency. Welcome to you, Libby. And I just want to show our viewers, first of all, a picture of yourself, a lovely picture you tweeted earlier. I think we can just bring that up. This was you in 2004 in French Guiana at the launch of Rosetta. And as we can see, you've written on your tweet, I was a graduate. ESA Rosetta's 10-year journey seemed like a lifetime to me. I had no idea what the future held. So, fast forwarding back to today then, what have been the most amazing discoveries so far, in your estimation, from this whole project?
Well, we've never had a spacecraft that has done anything like this before with a comet. All the previous visitations of comets by spacecraft have been flybys, so they've been fantastic. But to spend 2 years orbiting this comet, getting up close, sending Philae down, has opened our eyes, and we've seen so much. So we've just, for me, the most exciting thing is just learning so much about comets, so much about where they come from, what it might mean for life on Earth.
And the most surprising thing so far, perhaps?
Oh, I think one of the biggest surprises has been that discovery that the water that we thought or we might have seen is different to water here on Earth. So it's a different flavour, and that has surprised many scientists because it wasn't what we were expecting.
And that photograph we showed of you just a second ago, you were a graduate. In a way, you were telling me just before we began this conversation, it didn't seem so real to you, the impact that this project was going to have, that Rosetta would have?
Not at all. I was 23 or something. It was amazing to see a spacecraft launch. It was the first time I'd ever seen a launch. But it was this spacecraft that was going to this far-flung comet that nobody had ever heard of or could even say Churyumov-Gerasimenko at that point in time.
Well done. I'm not going to try that.
And yeah, it was just going, and you know, sometime in the future we'd get there. And then it had a wonderful journey there. It did flybys. We saw asteroids up close. And then there was this point in time where we had to put the spacecraft into hibernation. We had to basically switched the spacecraft off. We certainly stopped it communicating back with us here on Earth, and that's very unusual. So it was a really interesting journey. And then when it woke up, the European Space Agency and everybody has done a fantastic job getting people excited by this, describing the science, explaining what's going on. So we've had everybody really excited and captured by the fantastic science and the images that have come back.
So tell us more about the involvement of the UK Space Agency and what all of this means for it.
Well, there are 20 scientific instruments on the Rosetta probe that's been orbiting the spacecraft and on the Philae lander that landed a couple of years ago. And 2 of those have been designed, well, been part of here in the UK. One of them, which was led by the Open University, was an instrument called Ptolemy. That was on the Philae lander. It's what's called a gas spectrometer. It sniffs the air, and it's whilst Philae was coming down and landing on the surface of the comet, Ptolemy was taking measurements. It was detecting the composition of the comet and has sent back science for us to see. So that's been a really important instrument. And then Imperial College has been part of the Rosetta Plasma unit, which has been a group of instruments that are looking at the plasma, at the atmosphere, at the gases that swirl around Rosetta. So we've had 2 universities being a big part of the mission.
And of course, we should remember that when this, I suppose we can call it this slow collision between Rosetta and the comet happens, because Rosetta is moving at walking pace, that isn't the end of the mission, in the sense that the analysis of the data that Rosetta has collected, that's going to continue for a very long time, isn't it?
For decades to come. We've had this amazing data coming back. We're still looking at it, we're still seeing things. Rosetta will be collecting measurements right down up to that moment of impact and trying to send back as many things as possible, images, data, and that will keep scientists busy for a long, long time. They're looking, comparing that data with other probes as well.
And so many years of work, it's easy to see why people are feeling emotional about this. And I wonder, in your view, why Rosetta has captured the public's imagination in the way it has.
That's a very interesting question. It's been a mission that's been around for 2 years. There was the 10-year journey, as I mentioned. So I think it's a story that we've been able to follow. We've seen these amazing images of something that we've never seen before. We're perhaps all very used to seeing pictures of Mars now. So it's just been something new and exciting. And space always has an amazing ability, I think, to just open everybody's eyes to the fantastic world of science.
Libby Jackson from the UK Space Agency, thank you very much indeed for your time. And later on BBC Newsroom Live, we'll have live coverage as the Rosetta probe crash lands into Comet 67P. Now the time is almost 11:15. Heads of state